Bismillahirrahmanirrahim. I'm Tamia Gilani from Biotechnology, and my topic of presentation is antimony. So let's discuss what antimony actually is. Antimony is a chemical element with symbol Sb belonging to group 15 of the periodic table. Here is the picture of the antimony. It is a lustrous gray metalloid that is very brittle and has a flaky texture. Antimony has been known since ancient times. Now we discuss the discovery and structure of the antimony. First, the discovery. A French chemist, Nicolas Flamel, was the first person to scientifically study antimony and its compounds. Then he published his findings in 1707. Chemical structure. Antimony actually adopts a layered structure whose layers consist of fused, ruffled, six-membered rings. The nearest and next nearest neighbors form an irregular octahedral complex with the three atoms in each double layer slightly closer than the three atoms in the next. Here is the picture, as we can understand more clearly. So here is the atomic number of antimony, which is 51. Atomic mass is 121.7 AMU. Melting point of antimony is 631 degrees C. Boiling point of antimony is 1587 degrees C. And the electronegativity of antimony is 2.05, as antimony is a member of group 15 of the periodic table. Here is the chemical properties of antimony. These are: it does dissolve in some hot acids, but it does not react with cold water or with most cold acids. It often reacts with materials that do not react with either acid separately. Antimony is a moderately active element. It does not combine with oxygen in the air at room temperature. Antimony is a poor conductor of heat and electricity. It is stable in dry air, and it is not attacked by dilute acids or alkalis. And the physical properties. Actually, antimony is a silvery white, shiny element that looks like a metal. As we have already seen in the picture, it has a scaly surface and is hard and brittle like a non-metal. It can also be prepared as a black powder with a shiny brilliance to it. So the melting point of antimony is 630 degrees C, as we discussed, and its boiling point is 1635 degrees C. It is a relatively soft material that can be scratched by glass. Its density is 6.68 grams per cubic centimeter. So now we discuss how do we obtain antimony. Antimony and its compounds actually are naturally present in Earth's crust and are released into the environment by natural discharges, such as wind-blown dust, volcanic eruptions, sea spray, forest fires, and biogenic sources. Some antimony is produced as a byproduct of smelting ores of other metals, mainly gold, copper, and silver. In countries such as the United States, Canada, and Australia, important amounts of antimony are yielded as a byproduct of copper and silver mining. That's how we obtain it. And then we discuss the countries which produced antimony. And the first country is China. China's antimony mine production amounted to approximately 80,000 metric tons in 2020. Thus, China was a leading producer of antimony in the world. Russia and Tajikistan then were the second and third largest producers of antimony. Now we discuss the uses of antimony. First, antimony is used to increase the hardness of alloys, with lead alloys for batteries, with lead copper tin alloys for machine bearings. The second use is it is also used in automotive clutch and brake pads. The other major use is as antimony trioxide, which is used for the production of flame retardant chemicals. Antimony is used in semiconductor industry for certain silicon water, diode, and infrared detector productions. Small amounts are used in production of safety matches. Very pure antimony is used to make certain types of semiconductor devices such as diodes and infrared detectors. Again, uses and applications of antimony. Antimony is alloyed with lead to increase lead's durability. Antimony alloys are also used in batteries, low-friction metals, type metal, and cable sheathing, among other products. Antimony compounds are also used to make flame-proofing materials, paints, ceramic animals, glass, and pottery. The ancient Egyptians used antimony in the form of stibnite for black eye makeup. Now, what antimony affects on human health? Exposure to antimony occurs in the workplace or from skin contact with soil at hazardous waste sites. Breathing high levels of antimony for a long time can irritate the eyes and lungs and can cause problems with the lungs, heart, and stomach, including vomiting, diarrhea, and stomach ulcers. Exposure to high levels of antimony from occurrence in the workplace or contact with contaminated soils can cause difficulties with the heart, liver, lungs, and stomach. It can also cause irritation to the eyes. Left in direct contact with skin, antimony can also cause irritation. And now we discuss what effects of antimony has on the environment. Antimony can be found in soils, waters, and air in very small amounts. Antimony will mainly pollute soils. Through groundwater, it can travel great distances towards other locations and surface waters. That's how it affects our houses too. Laboratory tests with rats, rabbits, and guinea pigs have shown us that relatively high levels of antimony may kill small animals. Rats may experience lung, heart, liver, and kidney damage prior to death. Animals that breathe in low levels of antimony for a long time may experience eye irritation, hair loss, and lung damage. Dogs may experience heart problems even when they are exposed to low levels of antimony. Animals that breathe in low levels of antimony for a couple of months may also experience fertility problems. Whether antimony can cause cancer has not been fully specified yet. Thank you. Here is my presentation.